Good morning, everybody. My name is Marcelo Fernando Condori Mendoza. I am from La Paz, Bolivia, which is located in South America. First of all, I would like to thank Nikita and Mahesh, the main organizers from the Society for Space Education, Research and Development. I want to thank all of you attendants, students, and other professional staff involved in space engineering technology and applications. The topic I'm going to describe about is related to advancements in rocket technology. Let me begin my presentation with a brief history of rocketry. Let's talk about rockets. Well, there's a lot of biography about rockets, but we can describe it initially as being a distraction purpose. So ancient rockets were first developed by Chinese people. They applied this this exhibition for special events and situations, mainly for distraction purposes. As you know, the Chinese people have also developed other technologies like the powder, for example. Then we are going to talk about the rockets which were applied in the warfare. So the main idea was to launch them so they would able to damage other vehicles, or in this case, shipboard. Some decades later, rockets were intended to be one of the most fascinating inventions in which humans just wanted to see them fly away. By the early mid 20th century, rockets were intended for more specific purposes, as applied in the Second World War, when Germany, before beginning losing the Second War, implemented and launched the first the first rocket, which was able to damage some of the some of the war resources from the Union Kingdom. Unfortunately, they weren't able to develop it before, so this initial advance was just the beginning of more technology to apply later. As you know, main technology was exported to the United States. So since the 1950s, the ideas was already implemented in order to launch rockets into the space. And of course, some years later, the main idea was to launch the human into the space. So nowadays we can talk about the future rockets, which just take the best of technology in order to use the general structures and reduce somehow the high budget which is involved in this area research. I want to describe the voice launch system now. I will make you a brief overview in this topic. In the picture, we can see a NASA base station, which takes into account the main structure for a base station for rocketry launching. So actually, the SLS is an advanced launch vehicles that provides the foundations for human exploration beyond Earth's orbit. So we can imagine the SLS as one of the most initial strategies in order to apply rocketry launching. So how can we describe the power to explore beyond Earth's orbit? Main America's future needs were intended for space mission, which were increasingly demanding more powerful configuration. We can talk about 25 metric tons of weight about an SLS vehicle. So that means that 57,000 pounds approximately are launched into the orbit, right? For example, the moon. In the image below, we can appreciate several architectures from different rocketry belonging to countries such as India, the United States, Japan, Russia, and China. These and many other countries have already implemented rocketry engineering for both fabrication and launching. I'm going to describe the main idea of the rocket, right? So we can imagine this as a very big module which has disassemblable modules. In this case, the main structure is called the core stage, which is going to have enough space in order to accommodate the solid rocket booster. Then we have the launch vehicle stage adapter. There are other important panels which are encapsulated in the main structure which is launched into the space. We can talk about the service module, the crew module, right? Finally, the launch abort system. But what's the main purpose of the rocket? Well, actually, the rocket takes into board main payload or spacecraft, which can take into account a satellite or a space station mission. We can describe several situations like the SpaceX, which is a very important company, in which I will be describing in the next slides. In this case, we can appreciate plums from a flight of Falcon 9 rockets. And in the second picture, we can have a general idea of how the future launching schedules will be implemented from the SpaceX company, right? They are, for example, have intended and planned a launch by mid 2021. So now I will tell you what is SpaceX. Actually, SpaceX is a company, right? It's one of the most famous companies involved in the rocketry industry. It's an aerospace manufacturer and space transportation, which is headquartered in Hawthorne, California, and was founded in 2002 by the entrepreneur Elon Musk. In the below image, we can see an Airbus A321 on the final assembly line in the Airbus Platt and Harbour Finkenwerder Airport. So we can appreciate the high dimension of infrastructure and all necessary engineering which should be applied for developing assembly. So how does exospace become important? There was an artist's conception of a human Mars habitat, the idea that humans are going to explore and conquer other planets around the orbits, right? So this is just 3D printed, right? Made with water ice, airlock, and pressurized Mars rover. So the idea is to reduce the space transportation. We already know that this industry involves a lot of money. So the main idea is to reduce considerably those high budgets. So colonization is feasible for humans. We can talk about several launch vehicles from SpaceX, such as Starlink, Dragon, and the last projects which takes into account the Crew Dragon Demo 2. As we can see, Elon Musk conceptualized Mars Oasis, in which a greenhouse was intended to be implemented on Mars. So this would be the farthest that lives ever traveled in an attempt to regain public interest. So the main idea of this project was to get attention from several organizations and private companies, so enough interest would be generated to justify the huge investments. We should also mention their main competitors, which are Arianespace, United Launch Alliance, and International Launch Services. So this is the general idea of how the Mars Oasis would be developed and implemented in Mars. Now I am going to talk about the main achievements from SpaceX. It became the first privately funded liquid-fueled rocket to reach orbit. We are going to talk about the fuel in a few minutes. So this project is a Falcon 1, which was launched in September 28, 2008. Then SpaceX is also the first privately developed liquid-fueled rocket to put a commercial satellite in orbit. That came in July 14, 2009. Became the first private company to successfully launch, orbit, and recover a spacecraft, which is a very interesting engineering task, developed in December 9, 2010, and became the first private company to send a spacecraft to the international space, called Dragon C2, on May 25, 2012. There are many more achievements, but we can mention them as very high achievements which helped the rocketry industry development. Now I'm going to talk a little bit about propulsion. It's quite important to understand this part. So we are going to understand a rocket as a container, right? In this case, we can imagine a container, for example, as a medium to small in base, which is containing some material. And this material should provide enough energy to make a considerable movement of the unit. In this case, that contained material is gas, right? But this gas is applied under several levels of pressure. So a small opening at one end of the container allows the gas to escape in one direction. That provides thrust that propels the rocket in the opposite direction. So, as we can imagine, the main idea is to manage and control that direction so the rocket can reach acceptable or desired altitudes while traveling. And now I'm going to mention what is propulsion. This is a very important concept in order to understand the main engineering and functionality of this rocket movement and traveling. So propulsion is the act of moving or pushing an object forward. We can imagine, right, like pushing the rockets into the air, right, as a 90-degree direction from the main ground. This word is derived from two Latin words, pro, meaning before or forward, and pellere, meaning to drive. So the idea is not only to go forward, but also to drive, right? To drive, to maintain a stable direction. So the propulsion system is an engine that produces thrust to push an object. I am going to talk about the variable mass systems, in which certain variables from physics are taken into account for study. We can describe, for example, the first equation at a certain time t, where in this case we are going to talk about the variation of the velocity and the variation of mass. We are taking also the variables m and u. In this case, we can mention that the velocity is proportional to the variation of velocity is proportional to the variation of mass. So basically, the propulsion, which is represented by the speed of propulsion, is expressed in meters per second, and the rate of propulsion is expressed of unity of mass over a unity of time, right? So that's it. We are talking about the mass multiplied by the variation of velocity divided by the variation of time, which is equal to the speed of propulsion multiplied by the variation of mass divided into the variation of time. So the force on rocket comes by the hertz by propulsion. and after a several time, it's going to take into account the time plus aberration of time. Now I'm going to talk about rocket propellant. What is propellant? That's the main concept we should understand. We already understand the concept of fuel, right? Fuel is basically the energy source in order to move motor vehicles such as cars or trucks, right? So actually, the propellant is going to be the equivalent fuel which is used for rockets. It's a chemical mixture burned to produce thrust in rockets and consists of a fuel and an oxidizer. So it's not only a full and important requirement, but also the oxidizer. As we are generating combustion, the oxygen provides the necessary feeding element, so it can let the fuel get combusted. So the fuel is a substance which burns when combined with oxygen, producing gas for propulsion. And the oxidizer is an engine that releases oxygen for combination with a fuel. Now we understand why both elements are crucial for making the propulsion. As we already understood the chemical propellants as chemical fuels, we can mention different propellants which were being developed through the years. We have the solid propellants, which consist mainly of powder or gunpowder. They could be homogeneous or heterogeneous, which make a composite of elements. In case of liquid propellants, we can mention monopropellant and bipropellant, which takes into account petroleum, cryogenic, and hypergolic. Then technology is allowing the hybrid propellants to be developed and implemented. So this is the main architecture functionality of the engine for the rockets. So we mentioned the two main elements, the fuel and the oxidizer. So they are separated in specific capsules, which came into a shaft initially. The turbine in this case is kind of applying a is letting the pre-burning stage. So these are released out in the combustion chamber in order to generate the thrust, which provides the sufficient energy for the rocket functionality. So rocket engines are distinguished by the type of mechanism used to produce exhaust material. The simple engine is a compressed air bottle attached to a nozzle. The most common rocket engine is the chemical type, in which hot exhaust gases are produced by chemical combustion, right? We already mentioned the fuel and oxidizer. This is just a general overview in which we are taking into account the force, which takes into account the mass, the velocity, plus the difference of pressure applied, multiplied for a specific area. So in this case, we can mention, right, the nozzle. The nozzle is equivalent to a bottle, right? And it lets the exhaust combustion, right, which provides a velocity and the pressure, right? There's an entering pressure and output pressure which is applied in this system. So in the solid chemical rocket, the fuel and oxidizer are intimately mixed together and cast into a solid mass. Rocket engines. We can describe these two main different specifications. So, as you can see, the liquid fuel rocket is going to take the liquid fuel in the upper part, the liquid oxidizer. It's going to contain both bumps, by which both elements are released, right? And the combustion chamber basically lets the mix of both elements in order to generate the hot gases, right? Which is basically thrust and energy for rockets. And now we can mention the solid fuel rocket, which is displayed in the right figure. It basically contains the solid fuel and oxidizer, right? There are sparks in its core which burns from inside to outward. So there's a mechanism inside which is burning these elements. So outward is emanated a combustion chamber, which of course generate hot gases. So both are main basic engineering techniques applied for rockets. We can mention three families like the engines Merlin, the SpaceX, and Super Draco, and Raptor, taking into examples. We can talk about now about the liquid bipropellant chemical rockets. So basically, we already have the same structure in which oxidizer and fuel are applied, right? They are separate. They are actually extracted in the pumps. So later there's a turbine which works through a gas generator, and the valves are open, so both of them generate the thrust chamber. In the other case, we have the pressure-fed rocket, which just contains high-pressure gas for both tanks, including the oxidizer and fuel. The valves are open, so they generate the thrust chamber. So basically, these are some mechanism for bipropellant chemical rockets. What's the liquid monopropellant rocket? Certain liquid chemicals can be made to form hot gas for thrust production by the composition in a rocket chamber. The most common, such as monopropellant, is hydrogen peroxide. So in this case, we are having a pressurant, then we have the monopropellant, we have the thrust chamber, and the nozzle. The nozzle in this case is going to let the gas out. So the propellant is going to be a chemical element like hydrazine or monomethyl hydrazine. And the thrust can be generated from 1 to 4,000 newtons, mainly used for reaction control system, right? So that's a general idea of a monopropellant thruster. So how other technologies are coming by? We can mention nuclear technology as a valuable one, which is letting some advances and improves on rocketry. In this case, we are also going to talk about a propellant tank, a pump, and there will be cold propellants fuel, which is going to be uranium, right? There are atomic elements. So a reactor is implemented, which produces the heated propellant, which is later expelled as thrust by the nozzle. Research and development on the use of a nuclear reactor as a rock's energy source is currently being carried out in Project Rover. The nuclear rocket does not utilize any combustion process. That would be one advantage, like not generating combustion. But of course, the engineering should be well applied in order to use the energy optimally. We can mention one of the NASA's nuclear rocket, right? This picture belongs to, well, this was taken June 9, 2019. So this kind of project is intended to be implemented from the rocket to Mars, right? in which nuclear power is the main solution. In this case, we are going to have a general similar engineering for the rocket, right? Which is going to have a nuclear electric rocket to power ship to Mars, and nuclear thermal rocket to leave the Earth orbit. And the boosters lift the rocket into low Earth orbit. If we go inside the nuclear thermal, we are going to see the second image, which contains the liquid hydrogen, is flash vaporized by pumping in through the core of a nuclear reactor. So there is the liquid hydrogen, right? So this liquid hydrogen is released out into the fuel rods, which in combination, well, which result from the nuclear reactor, right? And that material, which is generated by the nuclear reactor, in combination with the liquid hydrogen, generate the thrust applied for the the thrust which is released out from the nozzle, and this thrust from hydrogen gas, which is up to 3 times that of conventional fuel. So when this technology and mechanism is properly applied, it can be more advantageous in terms of um, conventional fuel. Now we can see in the third image the general architecture and structure of the fuel rods. As we can see, the liquid hydrogen is surrounding this general structure. So in this case, enriched uranium pellets are inside the main car. And in this way, that the chemical reaction is letting the hydrogen gas out. So this chain reaction from uranium heats hydrogen to over 2,700 degrees Celsius, but makes it slightly radioactive. Well, that would be most important issues and topics I wanted to talk about nuclear advancement today. Now I would like to have an activity with all of you students. So I am going to mention one important activity that you can do by your side. Actually, it's going to be your homework. What do I want all of you to apply? Well, let's make our main activity, right? So I would like that you take a plastic bottle and make your own rocket. So what you're going to do is just to make your rocket, and once you make your own rocket, you are going to take a picture of it, and you will upload that picture as your homework assignment, right, in the platform that you have already been using some days ago. So in the next slides, I am going to show you how you can design your rocket in this case, right? Using just plastic materials or some other materials, right? So we already understand the main components. So the main components of a rocket are the nose cone. It has the pressurized air, the pop bottle, the water, the fins, and the nozzle. This is in terms of a more domestic rocket, right? This is kind of a domestic rocket. So actually, this might be understood as a water rocket, right? So basically, it contains the structure of a bottle, right? So it's going to release the water out. And we already understood how rockets fly, right? The main idea about the rockets is that we can apply some pressure, and the pump is going to be applied for this purpose. So we are going to generate, well, we are going to pressure, right? We are going to make some force, so we generate enough pressure. So Once enough pressure is released, in this case, the rocket is going to go up, releasing out the water, right? And also it's going to work thanks to the pressurized air it contains inside. That's one of the approaches. And this is basically right the same structure I mentioned below, but it is also reflecting some important physical interactions into the environment. So you understand that the thrust is generating up. So there are two forces which counterpart these thrusts. That's going to be the weights of the rocket and the air friction, right? We have again the nose cone, pressurized air contained in a pop bottle, water in the lower part. So fins nozzle. The nozzle in this case is just the small hole, right, in which the liquid is poured out. So instead of pouring the liquid out, it's going to expel the water with certain energy in this case. And there are several drugs, right, to design these water rockets. We can talk a parabola design, a give. We can think about a cone or a blunt, right? So of course there's plenty of information describing the main purposes of using these kinds of architectures. All right, but the main fabrication is going to implement these rocket fins. So once you are able to design the main rocket fins, you are going to have a certain structure, right? So actually, you are going to adapt in this case, those yellow features, right, according your own design and imagination. In this case, this is for example, just a plastic bottle, which was painted with black paint, right? As you can see in the lower and the upper part, basically it's a fusion of two bottles, and only elements were implemented as the other engineering of the rocket, right? As you can see in the water symbol sides of this single stage rocket. So we can talk about also the multi-stage rockets, right? We mentioned multi-stage rockets because it's composed of several other stages. As we can see in this case, this has three subsystem rockets initially, but there's also a main one in the main core uh, part of this rocket, right? That's the way it's working. And I would also like to mention you about some safety measures which should be applied so there's no risk of getting damage or making hurt. So it's necessary to select a grassy field for the launch. In this case, you can place the launcher in the center of the field and anchor it in place. As you set up the rocket on the launch pad, observers should stand back several meters. Do not point your water rocket at another person, animal, or object. So obviously, the main idea is to point it to the most vertical position as possible. And you also have to take care into account a possible area or region in which the rocket is going to fall down later, right? So the bottle should be pumped no higher than 50 to 90 psi of pressure. That's a limitation limit in order not to take too much risk when launching. So this is basically the activity which can be implemented. In this case, you are just going to design your own rocket with two bottles of plastic. And you can apply your own imagination and available materials, right, in order to design the color and the general architecture of your rocket. In this case, the pressure, well, I mentioned it before. In this case, pressure air is generated, so that will be enough in order to generate inside the pressure air into the bottle, so it can be released. Well, it can be thrusted into the air, right, in a certain direction. This is also just the same idea, but as you were able to see in the upper part, just another kind of geometrical figure is applied, right? That's more like a cone design. So that's your activity attendance, students. So I would like you can, well, in this case, you at least can try designing your own rockets. So you might have between 2 and 3 days in order to complete this activity. And well, let's make it fly. Fly it. Now there's some information about myself. If you have some other inquiries or consults, now I would like you, I am going to reply some questions or inquiries you might have.
Marcelo,
You
here are some questions from the students. Which is the latest rocket sent from NASA?
Sorry, could you repeat the question again? I didn't hear you well.
Yeah, sure. Which is the latest rocket sent from NASA?
All right. Well, I was reviewing information regarding the nuclear rockets, right, which are still being studied. Well, according to the information I reviewed, the latest rocket, which was launched by NASA, at least the most important one is that which led led a mission, right? I am going to mention the most important one. Just a second, I already mentioned it. So the most important, at least, is the one which was launched in May 25th, 2012, applied for sending the spacecraft to the International Space Station.
Okay. Can rockets be made reusable?
Sure, rockets can be made reusable. Actually, if we review technology and rockets launching, most of them were actually not being reused, but precisely one of the main projects from Space was to design the rocketry structure so these could be reused in later projects. So actually, that's also one of the main achievements from SpaceX. So they were able to actually to reuse a rocket structure for launching. Yeah, there's the technology today to apply that approach.
Okay. And how much a rocket cost? I mean,
Well,
money.
actually, I don't have the exact value at this moment, but of course, it's a millionaire budgets. So we can mention some implemented projects. For example, um, A communication satellites involves like 200 to 300 millions of American dollars, right? So the design of the design of the rocket, of course, all necessary engineering for the SLAs, right, which is the launching system, takes some amounts of that budget. So the minimum budget for designing and also launching the rocket, it's going to be like the minimum, like 80 to 100 million of dollars. That would be the lowest cost of a rocket. But of course, other kinds of projects might be more economic. If we, for example, think about microsatellites, of course, the cost is not going to be so high. But just that's just a reference, so you can think between budget between 50 to even 800 million of dollars. It's also going to depend on the weight and the kind of project which is implemented. Of course, the technology is also involved in the price of the rocket.
Okay, and which type of rocket fuels are better for interplanetary missions?
All right. Well, it depends. Which kind of rocket fuels are better for interplanetary missions? All right. Traditionally, liquid propellants have been more widely used, even though other engineering techniques as the solid propellant or the last nuclear rocketry technology would be a better solution. Even though, for example, the nuclear engineering rocket solution is still being developed and further implemented in several projects, right? So it's maybe the idea is not to mention the best. Well, I cannot say that a specific approach of rocket fuel is the best, but we can mention main advantages of them. For example, as I was describing the rocketry engineering, it's a more advantageous in terms of the thrust which generates a combustion, right? Since combustion is not generated, less gas is emanated into the air. That would be an advantage in terms of environmental caring, even though the engineering should be well designed and fit security and safe requirements.
Okay, and can you please explain monopropellant and bipropellant again?
All right. Okay. I am going to go back to my slides in order to explain these two propellants better. So just give me 1 minute to go back to the slides again. Is my screen viewable again? Can you see my screen? Well,
Yeah, yeah, Marcelo, we can see your screen.
thank you very much. So as we can see in the image, we understand the propellant as having two propellant elements for the chemical combustion. and the monopropellant is just going to use one element, right? One propellant for combustion. That would be the main difference. But I am going to explain a little more about them. Talking about bipropellant chemical rockets, there's always going to see an interaction among them. We can imagine as mixing them, right? Basically, it's a strategy of mixing them. But of course, since we are talking about full oxidizer, these elements are not isable mixed. That's the reason pumps are previously applied. So a gas generator is going to somehow transform the elements. So once they are properly heated, right, they reach appropriate temperature. Then the bulbs are liberated, so they emanate and mix together in order to generate the thrust chamber. And we can also use a high pressure gas in the upper part, right? So that higher pressure gas is going to make them released out more fluently when passing through the valves. So that's the other technique in which they are going to lead the thrust chamber. And when we talk about the liquid monopropellant rocket, the main difference might be the use of a pressurant. Actually, if you see in the image, this pressurant is exactly the same engineering, because in the second approach of the bipropellant chemical, also elements of pressuring are applied. So in this case, it's exactly the same, but we are talking only about one monopropellant, right? Which is released out. So in this case, an iridium-based particle catalyst is applied. So that's a specific engineering, a chemical engineering, in which the iridium particles actually are interacted with these monopropellants. And in that way, the thrust chamber is, well, we have the thrust chamber, which generates, in this case, the energy, right, which is released out by the nozzle. That might be the main difference, especially because we are actually using two different kinds of elements in those cases. In the first bipropellant, we will always have the oxidizer and the fuel as main propellants, right? But when we talk about one monopropellant, we are just talking about one element such as hydrazine and monomethyl hydrazine, which is in this case not interacted with another propellant, but instead interacts with iridium-based with iridium-based particles. That's the main difference between these two kinds of rockets.
Thank you so much, Marcelo, for explaining again. Um, which is, please, can you tell me the rocket with maximum capability in the world?
The rocket with maximum capability. All right. Well, we can mention the higher capabilities of rockets. Talking about the space missions, in basic terms, we understand rockets were mainly developed and deployed for getting satellites into the space. That's the main use of rockets. But interplanetary missions have launched actually more complex and sophisticated spacecrafts into the orbit, right? So those ones are actually the higher max capability, because they are having a payload which includes not only communication subsystems, but also modules which are going to be left into the orbits So they can be used as workstations, which are also going to receive and transmit information to smaller spacecraft. So what I can do is I can review more information by my side, and I can mention you these two questions you made. The first one was related with the latest rocket launched by NASA, and the second one related with the maximum capability rocket. But actually, the maximum capability rockets are the ones intended for launching mission spacecraft into interplanetary missions.
Okay, and why can't all rockets be used to go to the moon?
All right, I think that's a good question. Actually, it depends on the project. So we can think of rockets as different kinds of car transportation, as transportation cars. So a car, for example, might be specifically designed for very high velocity, right? While other transportation cars are more specifically designed for loading very high amounts, well, high amounts of mass, right? Like the heavy trucks. So that might be a reference for rockets. Well, that may be a reference. So in this case, obviously, not all rockets are going to reach the moon, since their initial purpose might be other than letting the rocket arrive to moon. Actually, the rocket itself does not reach a very far away planet, because what I can explain is that the rocket is used as a base for launching the main spacecraft. So a lot of resources are applied. Let's imagine in this way. Let's suppose that you have 1 kilogram of mass, right? So in this kilogram of mass, like 80% is going to be the rocket infrastructure. And only 20%, that would be like 200 grams, corresponds to the spacecraft. This could be a satellite. So the rocket actually is going to be disassembled in certain stages. When it reaches a certain height, it's going to disassemble, for example, the lower parts, and only the upper parts remained in the higher distance. So actually, any rocket, actually rockets do not land on the planet's surface, but they let the spacecraft reach enough altitude and reach appropriate distances in orbits, so the satellites or the spacecrafts can be put into orbit. That's the main idea. And of course, why some rockets do not reach the moon? Because they were intended for other purposes, like leaving rockets to a lower distance, right? We can think, for example, as reaching, let's suppose, like 36,000 kilometers above the sea level, right? But we can think about the microsatellites like reaching lower than that, like, for example, 10,000 or 5,000 kilometers, right? That's the main reason why not all rockets can reach moon, right? And actually, the rockets do not reach the planets, but they just provide enough altitude and use quite amount of energy in order to put satellites and spacecraft into orbit. That's the main issue and strategy of rockets.
And can potassium permanganate be used for rockets?
All right. Can potassium permanent be used for rockets? All right. potassium permanganate be used for rockets. To tell you the truth, I didn't read about these elements. So, is it possible I would apply some more research, and I would be able to reply that question better. Talking about the potassium permanganate, right? Used for rockets.
Okay, sure, no problem. Okay, and what is the most commonly used fuel?
All right. Actually, the most commonly used fuel is the combination of the oxidizer and the propellant. That's actually the most used rocket. That's actually that's still the most used rocket today. So I was describing already, right? The main strategy. So fuel and oxidizer are processed in pumps. So later they are released out in order to generate a combustion. Well, in order to generate enough thrust for launching up the rocket. So that's still the main used technology today.
Um, as concerning to environment of space, will rocket pollute the space?
Okay, that's a very good question. Well, actually, every spacecraft or any other module which is launched into the system, of course, pollute space. But we can talk about two kinds of pollution. The initial pollution is debris. So, as every mission or project, in this case, as every rocket is launched into space and releases out a satellite, actually, a satellite has a living period, right, in the orbit. Let's suppose a satellite can have a living period between 5 and 10 years. So after that period, the satellite is not going to work anymore because no energy is sustainable for longer periods, and it's very difficult and expensive to take back that satellite into the Earth. Of course, there's certain regulation and projects which are intending to bring back certain satellites or main engineering modules to the Earth. But in general cases, those satellites just keep into the orbiting in the orbits. So sometimes they crash against asteroids, or they can even crash among other satellites. So this generates, right, like a distortion as two cars which collide to each other. So materials are released out. So those materials are released and liberated into the space as dust. So that's one kind of pollution. And the other one, of course, we talk about propellants and combustion, right? That generates chemical elements, which, of course, produce a certain kind of pollution, especially inside our atmosphere. In terms of the outer space, it generates gases, but deep research can be applied to determine how much exposure that pollution, because that pollution would be very small in compared to other gases which interact in the outer space, right? So those are the main kinds of pollution. The one generated by debris, and the other one, which is much lower, but especially causes pollution in our inner atmosphere, in our inner environment. That's also the reason why other techniques which generate less combustion are intended to be implemented nowadays.
Okay, so can you please tell the students that what are we learning tomorrow?
All right, perfect. Well, there's one activity I am going to participate in tomorrow. It's about satellites. So that's an intended class for senior students. In that class, I am going to describe the satellite engineering. I am going to describe what the telecommunications satellites are designed for, what are the main functionalities and uses of remote sensing satellites. I think that's a very big area of research. So I hope all of you can attend to tomorrow's session. We can describe a little bit about processing images from satellites, because rockets actually work like this. They take into board certain payloads. That payload is released in the outer space, so that payloads is put into orbit. Once that payload it's put into orbit, it works as a satellite, right? And that satellite is going to provide certain information from the Earth.
Okay, Marcelo. So it's time. So shall we leave?
All right. Thank you very much. I really appreciate your help. And I was able to wrote down those three questions specifically. So I am going to also publish them so you can have more access to information. And do not forget your homework activity. Thank you very much. I really thank all of you for this opportunity.
Okay. Thank you. Bye.
Thank you. Goodbye. Thank you very much.